So we're in week 3, and we're going to go over chapter 6. Okay, so keep in mind it's chapter 6 in week 3. Okay, so we're going to talk about sequence and series. And what is that? So sequences are progression of real numbers in which the order of the numbers within the progression is relevant. What that means? That means we have list of numbers, and the rule to get the next number is going to be given, and the numbers are related to each other. So there is a rule how to get the next number. That's what that means, right? If you change the order, you're changing the sequence. So the order is very important in the sequence, okay? The numbers within the sequence are referred to as the numbers or elements of the sequence. So the first number is the first element. Usually this is how you write it. A1, A2, this is like a notation, A3, and so on. So these are the elements, okay? The elements of the sequence. And the number of terms, so how many terms, how many numbers you have in that sequence, usually it's an is the last one. So n, the number of terms, the n numbers in that sequence, is the length of the sequence. So the length of the sequence is the number n, okay? You can have 5 elements in that sequence, you can have 10, whatever it is, it's n, which is the length of the sequence. And of course, the length could be finite, or infinite. Okay, so if it continue forever, it's going to be infinite sequence. Any questions here? We talk about sequence in algebra. We just try to find a pattern, if you remember that, or you need to find the sum of the first 5. That's what we did in algebra. Here we're going to expand that. We're going to work with more kind of in general sequences, and we're going to talk about arithmetic and geometric, 2 specific sequences. Okay, so here we're going to talk about sequence and summation notation. So here you have examples. So the first sequence given is the Fibonacci sequence, and this is how they look like: 1, 1, 2, 3, 5, and so on till 233. They give you that number. So this is how you generate this sequence. Okay, you start with 1, and then you have 1, and then you add in these 2 terms to get the third one, then you add in the next 2 to get the next one. So every term is sum of the previous 2 terms. Make sense? So that's how the Fibonacci sequence looks like. There's another example. You have the numbers 2, 4, 8, 16, 32, 64, and so on. This is a sequence where each term is multiplied by 2 to find the next term. Okay, so that's the rule here. That's how the term looks like. And then you have another 2 examples, and let's find out what's happening here. So if I have the number 20, 25, 30, 35, what you're doing here? What is the rule for this sequence?
Adding 5.
You're adding 5, that's right. So adding 5 to each term to get the next one, right? How about the next one? The last example here in this slide. We have 1, 8, 27, 64, and so on. So what do you think it is? We have something like that in algebra.
Looks like it's, wait.
Cube, right? 2 cube.
Oh, yeah.
3 cube. 4 cube. And 1, of course, can be always 1 cube, right? Then
Are we going to need a graph?
Huh?
I'm sorry. Are we going to need a graphing calculator in this class?
No, not at all. No. Okay, so looking at the numbers, you can see what is the rule, what is the sequence doing. So here we are doing cubes of numbers, right? So this is how this sequence looks like. It's a list of cubes of all the numbers, 1, 2, 3, all the way to infinity looks like, because continue, right? So everybody understand the sequence? There is a rule how to get the next term, and sometimes they're going to give you the order. They're going to give you the few numbers, and they're going to ask you to find the pattern and find the next one. Sometimes they're going to ask you to they're going to give you the rule, they're going to give you the formula to calculate each term, and they're going to ask you to do something else. Okay, so keep in mind every sequence have a rule how to calculate each term. Make sense? Okay, and then the general term of sequence. What is general term? General term is the formula how to calculate, the rule or the formula how to calculate each term. And the general term, remember, the sequence is given with A1, this is the first term, A2 is the second term, and so on. AN is the end term. And this is called also general term. General term looks like this, AN, and is given as a formula. So here you have examples. Give the first 5 terms of a sequence called whose general term is, this is the general term. It's a formula, 3 plus n over n. So that gives you the formula how to calculate each term. And how you solve that, how you solve the example, you need to find the first 5. So you're going to replace, remember we did in algebra little table. So we have when n is 1, let me write it here. So we did this in algebra. If they give you the formula, you need to find the first 5. You're going to do, you can do it like this. N is 1 to 5, right? And then the formula, it's AN is this formula. This is the formula. So when n is 1, you're going to do A1 is 3 plus 1 over 1, which is 4, right? Remember doing this? You guys remember this from algebra? Yes, okay. Now when
It's been almost 20 years since I had algebra.
Oh, okay. We did this in algebra last semester. So most of the students here, they took my algebra class, and we did this in algebra last semester. Yeah. But yeah, thank you for saying that, because some of you are transferring credit, so you didn't take algebra for a while. But this is what you're doing. When n is 1, you replace n with 1 in the formula. So it's going to be right here. 3 plus 1 divided by 1. Simplified is going to be 4. Then you're going to replace n with 2, right? So in this formula, 3 plus 2 over 2 is going to be 5 over 2. And then you're going to continue. See, they have A3, A4, A5, and you calculate it using the same formula. Make sense? You guys understand that? Yes? Okay. So that's how you calculate the first 5, or whatever they ask you to calculate, whatever term. If they say find A20, so you're going to replace n with 20, right? So let's say they ask you, what is A20? I'm going to use the same formula, which is the formula to calculate each of the terms, and you're going to replace n with 20, so it's going to be 3 plus 20 over 20. And that's going to be 23 over 20. That's it. This is your term. This is the 20th term. Okay? So that's how you do that. They give you the formula, and this actually it's easier because you know the rule, you know the formula. You don't have to figure it out what is the formula, right? But you're going to do that also. So here, the next one is using the formula for AN, we can calculate the value of any n term. That's what I was just doing, right? Example, here they give me the formula. This is the formula. AN is this, the general term. Calculate the 200th term. So I'm going to replace n with 200. So plug it in. And that's it. That's your answer. Okay? Everybody understanding that? So this is straightforward. Just plug it in and you get what you get. You're going to get a number. Okay? The next
Where's the
example-
answer for
Yes.
that one?
Yes, this is the answer.
You said
159/80.
once you put 200 in for n,
Yes,
and
you
then
replace
do the
n.
math.
Yes, and then you do the math. You can put it in the calculator, simplify, and you're going to get 159/80. That's the answer. So the 200 number in that sequence, you have number 1, number 2, number 3, number 4, all the 200 numbers. If you do the sequence, the number in the 200 place is going to be 159/80. Make sense? Okay. The next one example we have here, to calculate the value of the 10th term. So you have to find the 10th term. Now, this is my general term. This is my formula. And what you're doing, you replace n with 10. So it's going to be -1/2 with exponent 10 minus 1. Here they did it step by step. You can just put it in the calculator the way it is. And this is your answer. So the 10th number in the sequence is going to be -1/512. Okay? Any questions?
What calculator? Just any calculator?
You can use any calculator. Symbol up. You can use symbol up.
Oh, symbol app. Let me write this
Yes.
down.
Yes, you can use any calculator.
And it'll give you the 1/512.
-1/, yes.
I didn't see that. Okay, thank you.
Well,
Why is it in -1 on the second example, but not the first?
that's how
Isn't
the
it the same
formula is.
formula, just a different
No,
10?
it's a different formula. Whatever the formula is, they give you the formula. Yes. Yes, thank you for asking that. So the formula is given, whatever they give you. It could be n minus 1, whatever it is. Okay? You have to follow the same formula. Okay? Any other
So
questions?
Okay,
the
so there's-
formula changes.
Yes?
Yeah, there's no set formula. It's always just rotating up to their questions.
Yes, it's going to be given a different formula. Yes.
Okay, just making sure.
Yes, yes. You guys have really good questions. Something else? Okay. So they give you the formula. If they give you the general term, they give you an equals is given. And they ask you to find the 200, whatever term they ask you to find. You plug that number into the formula and that's your answer. Okay? Now, next one we're going to do is we're going to have given a finite set of number of terms of sequence. There are going to be a lot of formulas. That's exactly what you're asking. Okay? There is no one right answer. Now, if I give you a sequence, now we're doing backwards. So they're going to give us a sequence and we need to find the formula. Make sense? So this is a little more difficult because they're going to give me here, they give me the numbers in the sequence. See, these are the numbers in the sequence. And we have to find the formula. Okay? Which is going to calculate all of the numbers in that sequence. So this is a little more complicated problem to do, okay? But that means we did this in algebra. It's not that difficult, but here we need to think about what is the pattern and how we're going to represent that pattern with formula. And this is what IT people are going to do, okay? You're going to create algorithms. You're going to create formulas, which is going to work for any situation. Make sense? So that's what you need to think about. Okay? So this is doing the same problem we just did before, but backwards. They give us only the sequence. We have to find the formula. Okay? And keep in mind, there is no one right answer. You can have different formulas for the same sequence, but the formula have to work for any of the numbers in that sequence. Make sense? So here we have this example. Let's look at this example. And they give you the formula, one of the formula, but this is how you find the formula. You're going to start analyzing the numbers, the sequence. So the sequence is 2, 5, 10, 17, right? So you need to see what's happened from number to number, right? And keep in mind the first number is A1, is 2, A2 is 5. So your formula has to be connected with n, which is the number here. Okay? And whatever the formula is, when you put 2 in the formula, you have to get 5. Make sense? Okay, the A3 given is 10. A4 given is 17, right? This is what we have. So, here we need to think about a formula which, when I put n is 2, is going to give me 5. So here we're not exactly looking what's happened from term to term. There's a formula, there's another way to represent, we're going to talk about that later, but now we need to find a formula which connects 2 and 5, 1 and 2, 3 and 10, 4 and 17. So we need to make a formula which, when I replace n with 2, I'm going to get 5. When I replace n with 3, I'm going to get 10. Okay? So here we have one example. N squared plus 1, which means 1. So this is 1. The first one is 1. Squared is 1. Plus 1 is 2, right? So works for A1. So this is 1 squared plus 1 is going to be 2. Then when I replace n with 2, it's going to be 2 squared plus 1 is also 5, right? So here they give us the formula, but technically that's what you need to do. You need to figure it out, what's going on, how we're going to connect the term with the actual value of the term. So the next one is 3 and 10. So when you square 3 and you add 1, you're going to get 10, right? The next one is the same way, A4. So it's going to be 4 squared, 16, plus 1 is 17. So you see that pattern here. We have 1 square, 2 square, 3 square, 4 square, and plus 1 is going to give you the term. That's how they have this formula. Okay? So we had a little help here how to get the formula, but pretty much you by yourself have to get to that formula. Okay? And then we have another example here. We have, this is fraction, and this is the formula they get from these terms, from these given terms. Okay? Any questions? We're going to do some example where we're going to find the formula. How the son is asking, how does one type okay, so Tyson is asking A2 opposite, y equals -4 plus 5x. Mark, I don't know, this is linear equation you're giving me here. So.
Oh, is it not a linear equation?
What is it then?
Oh, I just tried to solve for, find the formula for like 2, 5, 10, 17, etc.
You're trying to find another formula? Yes? Okay, so if you, yeah, you can find another formula, but it have to be in terms of n.
Oh, I see. Gotcha.
Yeah, it have to be in terms of n. So technically, if you're trying to find a formula, you have to connect 1, and you have to put 1 in the formula, you should get 2. You're connecting 2, have to be 5, right? So when you plug it in 3 into your formula, you should get 10. That's what you're connecting. The number of the term and the number in that sequence. Okay? So that's what you need to do. So the next one we're going to do is recursive sequences. So this is the sequence when they give you a sequence, we have to find each term is going to be represented in the formula with the term before. Okay? So this is how these formulas work. So sequence in which the initial term is called also the first term, or one or two of those or three of those, depends how your sequence works, like that works. So you need to know the initial term, and you also have a formula which relate the term before, one or two terms before. So here we have example, and here this type of questions are common in finance, biology, and physics, where future value of the variables depends upon the value of the variable at some earlier point of time. So this is what you keep in mind. Recursive means you're going to look before, you're going to look at the term before. Okay? So the examples we just did, if we need to find the recursive formula, you have the term 2, 5, 10, and 17. I'm going to use those numbers. 2, 5, 10, and 17. If I want to find recursive formula, this is going to be A1. So 2 is A1. And I have to find a formula which connects the next one. So 5, what is 5? Connected to the previous one. So it's going to be 2 plus 3, right? But you need to find what you're adding, technically. Or you're multiplying by 2 plus 1 plus 1 minus 1, 20 minus 3. So in this case, it's not quite, we need to think about more about finding a formula, but recursive means you're going to have the first term, like this example here. You're going to have the first term given, and this is the formula. See, the formula doesn't have an minus 1, which means the previous term. So using this example 1, the first term is going to be 4. What's going to be the next one? See, this is your formula. You multiply 2 times the previous. So the next one is going to be 8. The next one is going to be 16. The next one is going to be 32, and so on. Okay? So this is how the sequence is going to look for example 1. Okay? For example 2, again, we have the first term is 2. So it's going to start from 2. And then the formula, an, the general term, is 1/2 of the term before plus 2. Okay? So it's going to be half of 2 is what? 1 plus 2 is 3, right?
3.
That's right. The next one, what's going to be the next one? Half of 3. What is half of 3?
1.5.
1.5 plus 2 is 3.5, right? Then half of it.
4. Wait,
Oh, yeah, that's
it
right.
should be 4.5.
That's correct. Yes, yes, yes. Adding 2, not 1. Or actually, no, it's 3.5. Yes, that's right. You're adding 2. Half of 3 is 1.5.
Oh, I see.
It's right. Yeah, 3.5. Yeah. Okay, the next one, you're going to take half of 3.5, right? 175, that's right. And then you're adding 2, so it's going to be 3.75. And so on. Everybody understand the pattern? So what is important in this formula, in these formulas for recursive sequences, we have the formula connects the terms before. Okay? It's not connected with the place on your sequence. Okay? So these are the two different ways to get the formula. So I can get the formula for your sequence if you have given the sequence. One way is representing the formula general term in terms of n. So you're going to have an, and then you're going to have something with n. And another way, So this is like a general term formula. And another formula for sequences, if you have a recursive sequence, which means going back to the previous term. So you have formula n equals, and here you're going to have formula which is going to include n minus 1, a n minus 1, which is the previous term. It could be one term, it could be two terms, because if you remember, we talk about, let me go back here. We talk about the Fibonacci sequence, okay? So the Fibonacci sequence, you add in the previous terms, right? So if I represent this with recursive formula, is going to be like this. an is going to be an minus 1 plus an minus 2. You add in the previous two terms, right? And this is going to be a1 is 1 and a2 is 1. You have to have given the first two because in the formula has two terms before. And this formula is when n is bigger than 2. So we're going to start from 3. Or you can just say bigger or equal to 3. Let's do that.
I'm sorry, but I'm struggling to have a understanding of what a subscript n
Yes.
minus 1 is.
Thank you. Thank you for asking that. So that is which term, which number in the sequence you're talking about. So an is the nth term. So n, it could be any number. So you have the first number in the sequence, the second, so you have first, second, third number in your sequence, 100, whatever it is, and then you have n, right? And then you have n plus 1. That's how it is. N represents pretty much number, any number, in general. Okay?
Okay, so a n minus 1 would be
The one before.
would just be 1, right?
Okay, so this is how it is. Let me write it for you. So we have sequence. We have the first A1 is the first term, right? Then you have the second A2, and so on. Then you have A.
Oh, I see.
N
So you're
minus
just plugging
2.
the numbers.
Yes.
You're
N
just
minus
plugging the
1.
numbers that are in the list in that sequence.
Yes.
So for the first one, a n minus 1 would be 1, and then a n minus 4 would be 3. Right? Because it's the fourth number in the sequence.
No. If you're talking about Fibonacci sequence, A1 is 1, A2 is 1, A3 is 2, A4 is 3, A5, 1, 2, 3, 4, 5 is 5. What is A6? What is going to be A6?
Well, A5 is A.
No, A5 is 5. A6 is
13.
8. Yes. That's right. A5 is 5, A6 is 8. Yes. See, John is explaining what n minus 1 means. That's a good explanation. N minus 1 means the number one spot back. Yes, that's correct. Oh, sorry, where am I? Okay, so N1, AN is just one place somewhere. This is AN. N minus 1 is one place before. N minus 2 is one place before the N minus 1. Or two places from N. Two places back. Make sense? Yes, maybe?
Good to go.
Okay. Okay, so everybody good to go? Okay, so then you're going to come back. So everybody understand what is recursive sequence? There you go. This is my slide. Okay, so everybody understand what is recursive sequence? You represent the sequence with the formula which represents the term with the term before, one or two terms before. Okay, so now we're going to talk about factorials, and we're going to talk about the summation notation because we're going to talk about series. Series is adding and subtract, adding numbers in a sequence. Okay, so now what is factorials? We did this in algebra. Factorial is you start multiplying, see, this is the formula, n factorial is n times n minus 1 and so on all the way to 1. So if I want to find 7 factorial, you start from 7, 6, 5, 4, 3, 2, and all the way to 1. Multiply the numbers and that's your answer. You can use that in the calculator. You don't have to write it down like this. You just put this in the calculator. 7 factorial is going to give you that number, 5040. Okay? Everybody remember the factorials? Okay, I see thumbs up. The next one is summational notation. So the notation, we did this in algebra also. This is the sigma symbol. Sigma n is changing from 1 to k, from the smallest to the top, from the bottom to the top number. And an is the formula. So if I need to find sigma, n is from 1 to k, an is the third general term. That means I have to add a1, a2, and all the way to ak. Okay? And here you have example. Calculate the sum. Sigma n is from 1 to 5, and this is your formula. So you're going to replace n with 1, 1 square, plus you're going to replace n with 2, 2 square, n with 3, 3 square, 4 square, all the way to 5 square. You're going to put this in the calculator or just do it in your head. You're going to get 55. So the sigma 1 through 5 of n squared is 55. You got it? Okay, the next example we have is sigma from 1 to 10, and the formula is just k. So it's going to be k is 1, k is 2, k is 3, all the way to 10, and you're going to add those numbers, and you're going to get 55 again. Okay? So that's how you do the sigma notation. Now, we're going to talk about two specific sequences. We're going to talk about arithmetic and geometric sequence. So arithmetic sequence, it's a sequence, it's a list of numbers where the difference between the terms is constant. Okay? So for arithmetic, we have common distance. So we have list of numbers sequence where you're technically adding the same number from term to term. That's what happened. So let me give you an example. Example of arithmetic sequence could be, I'm just giving you an example, could be 1, 3, 5, 7, and so on, right? What I'm adding from number to number, I'm adding 2, right? Plus 2, plus 2, plus 2, plus 2, yes? You can add something, you can subtract something. So this is arithmetic sequence. We're going to add or subtract something to each term, okay? And adding and subtracting means if you add negative number, it's going to be subtracting that number, right? That's why I'm saying adding or subtracting, okay? And you're adding the same number. It's a constant number, okay? That's important, constant, okay? So here what you have the first term is A1, and the common difference, the number you're adding, it's D. So these are the letters we have. And this is the formula for this type of sequence. The first plus n minus 1D. Okay? So we have all these formulas. I have it in the formula sheet. So when it says arithmetic sequence, that means you have the common difference, which is D, and you have A1 is the first term in the sequence. AN is going to give me the formula to find whatever term I need to find. Make sense? Okay?
Can you do an example using that?
Yes, this is the example. We have initial term is 3, so that means A1 is 3. And the common difference is 9. That is given. The difference is 7. I'm sorry, 7, not 9. So the first term is 3. The difference is 7. So what is the term? How the sequence looks like? So start with 3. You add in 7. You add in 7. You add in 7. And this is what you get. Make sense?
And then you would just plug those numbers that you have in there into the formula for the general term for an
Yes.
arithmetic sequence.
The general term for arithmetic sequence is going to be if you want to find, let's say, A50. If you want to find a big number, big, whatever term in your sequence, 50th number in this sequence, instead of going all the way to 49, I can just skip to number 50 in that sequence. A50 is going to be 3 plus, I'm just plugging it into this general formula. 7 minus 1, I'm sorry, n is 50. So this is 50 minus 1 times 7. And that's going to give me the 50th number in that sequence. Okay,
No,
makes
that
sense?
doesn't make sense.
No?
Ow.
Yes or no?
I get it.
Not really.
Not really? Okay, so this is arithmetic sequence. So the first number is given is 3. So your sequence is going to start from 3 and you're going to add 7, 7, 7, 7 to each number to get the next one. So 3 plus 7 is 10, right? When you add 7 is 17. When you add 7 is 24, right? When you add another 7, you're going to get the next term. So this is the first term. This is the second term. This is, so technically this is A1, A2, A3, 17, right? A4 is 24. If I want to know what is A50, I'm going to put 50 into this formula, general term formula, and A50 is going to be 346. So what that means is I don't need to go all the way to 50 numbers to find, to add 7, add 7, add 7 to get to A50. I can just use this formula to find what is A50. Make sense? Now or? So A1 is the first number in your list, in your sequence, arithmetic sequence. And you know that you add in 7 to each of those numbers to get the next. So A1 is 3. When you add 7, you're going to get A2, which is 10. Then when you add another 7, you're going to get A3, which is 17. Then you add in 7 to 17, it's going to be 24, which is A4. If I want to add A5, I'm going to add 5. I'm going to add 7 to 24. But let's say I want to find A50. I don't need to find all the numbers before that to add. I don't need 49 numbers. I can just use the general term formula and replace A1 is, so in this formula, A1 is going to be 3 and N is going to be 50. And this here is going to be D, the common difference is going to be 7. So that's what I did. Any questions?
So suppose you use the equation and there is no geometric value or there's no arithmetic value to explain the sequence. How do you go about writing that down?
What do you mean there is no arithmetic value?
Like if there's no defined way to explain the pattern.
Okay, so if if it's arithmetic sequence, then you should have common difference. If it's not arithmetic sequence, then it's something else. Okay? Here we're talking about only arithmetic sequence. We're talking about only sequence which has common difference, which means you're adding the same number, constant number, to each term to get the next. Make sense?
Yes, doctor.
I understand it now. Thanks.
You're welcome. Okay, everybody understanding the arithmetic sequence? We have list of numbers, and the order is very specific. You can change them. You have specific order, and from number to number, you're going when you add the same common difference. Okay, so that's arithmetic sequence. So here, finding and using the general term. So the general term, this is your formula. Okay, we're going to use this formula, and I have it in the formula sheet. So if it's arithmetic sequence, this is the formula. Okay, and we need to do whatever they ask you to do. Okay, so here they ask you, the first example one we have, they give us the sequence and they ask us find the general term, so find the formula. Okay, so how you find it? To find the formula, you need A1 and D. So this is A1 is 3, right? And what is D? The distance is the distance between two of those. So you can do 8 minus 3. You can do 13 minus 8. You can do 18 minus 3. It's going to be the same number, so it doesn't matter. I'm just going to do 18 minus 13 is 5. So the common difference is 5 and A1 is 3. And when you plug it in this formula, it's going to be AN is 3 plus N minus 1 times 5. So now when I have this formula, I can find whatever term I want to find. I can find A50, I can find A100, whatever I want to find. Make sense?
Is it asking you what to find?
I'm sorry?
Is it asking you what to find?
No, it doesn't ask you here. They just give you it says find the general term. So they give me the sequence and ask me to find AN only. That's it. Okay?
And so AN is
AN
3
is 3 plus N minus 1 times 5. Yes. Okay? Everybody good?
Question on this one that you just did. The original formula is 8-1, and then at the solution says AN, right?
The solution say what?
It says AN.
Yes, AN. Yes. This is the formula.
Yeah, so the formula says A1 plus N
No,
minus
it's
1.
AN. AN. This is AN. AN this is the formula we're using.
Okay, gotcha.
Yeah. And this is also
Just out of
yes.
Just out of curiosity, I think someone tried to answer. How would you use these in computer science? Like, what would be? I'm not saying that we shouldn't learn it. It's just that how to help me understand. How would we use these? Like, where could I possibly see them in the future?
Okay. So where you can see them. Okay, there are a lot of patterns.
Python.
And when you make a code, depends what language you're doing. When you write code for different programming, you're gonna have to find a pattern. Okay, you have to create a formula so you can create the codes. Okay, so creating a formula, finding the pattern is gonna be the basic of your programming skills. Make sense? And somebody said Python. Yeah, one of the whatever you're using.
So with
language you're using, C++, whatever you're using, you have to create a formula to generate like cycles where you can create something. Okay, create the programs. Make sense?
So the user input would be like the sequence then?
Yes. When you create the formula, the user can just put different value and get the result. But you have to create the formula. You, like IT specialist, you have to create that code which is gonna calculate it. Make sense?
Yeah.
Okay. Any other ideas about where we can use, you can use that? I'm going to show you a video later on in the end of, after we finish the PowerPoint, I'm going to show a video where we have another very cool example of this. Okay. Okay. So ready for the next slide? Everybody understand that? You want to go over, let's go over example 2 also. Let's go over this example 2. And then we'll go. So example 2, you have to find the general term. So this is my sequence given 2, 6, and so on. So the first term A1 is going to be 2. And if I want to find the common difference, it's going to be subtract any 2 terms. Doesn't matter. 2 consecutive terms. So I can just subtract 14 minus 10, for example. So the common difference is 4. Plug it into the formula, and that's your formula. An is 2 plus 4 and minus 1. Okay? So that's how you do arithmetic sequence. There is a specific way to do that. Now, calculating the sum, again, we have a formula. To find the sum of the first 5 or whatever terms you want to find. So this is the formula. Sk is the sum. So if I want to calculate, if I want to add 5 terms or 10 terms, add them together. So calculated the sum of the first k or whatever terms you want to find in arithmetic sequence. We're talking about arithmetic sequence again. So this is the formula. You need to find the first term. You need to find the last term, divided by 2 and multiply by k. So that's how you do it. Okay? So here we have example. So this formula for the sum for arithmetic sequence also going to be included in your formula sheet. So this is the formula. If it's an arithmetic sequence, this is the formula you're going to use. Okay, so here you have example. Find the sum of the first 20 terms of the arithmetic sequence whose initial term is 0. So you have A1 is 0. And the common difference is 4. So the D is 4. So how are you going to find the sum? So we have A1 is 0. I need to find A20. And I'm going to use the previous formula where it says, remember the formula for AN, the general term? AN, I'm going to write it here. It's A1 plus N minus 1 D. So this is the previous formula using to find A20. So A1 is 0 plus N minus 1 because N is 20. Minus 1 is 19 times 4. Now here there is a typo. This should be common difference.
I was wondering why it switched to a negative.
It's minus 4. Yeah, this should be, this is a typo. Yeah, remember there was. So we're gonna multiply, and this is your number. The last term is this one. So A20 is negative 76. And then you're gonna add those two numbers. You're gonna divide by 2 and multiply by N, which is 20. And this is your answer. Okay? Everybody understand that? Okay? Then calculating the sum, we have another example here. And here you have this is actual question, which is kind of application where you can use that, the sum of the first k terms. So here we have, Suppose a college plans to design a field house in which a particular season of a balcony is constructed in such a way that the first row was 22. So this is the first number. So I have, it's like a sequence, 22. Then 25 seats is the second one, right? The first one is 22. The second row is 25 seats, right? The third one is 28 seats, and so on, right? Okay, so that's a balcony. This is how the seats are. And if the balcony has enough space to permit 17 rows, that means 17 numbers here. So this is A1, A2, A3, A17 is going to be the 17th row in that balcony, right? How many individuals can be seated in these balcony sections, right? So that means you have to find S, the sum, 17, right? You have to add the seats in the first row, which are 22 seats, the seats in the second, which are 25, and so on, right? So this is what you have to need to find, S17, okay? So we have A1 is given, this is 22. I have to use the, because this is arithmetic sequence. So I have to find what is A17. What is A17? Is A1, which is 22, plus 17 minus 1 is 16, times what is the common difference? What is the number you are constantly adding?
3.
3. So the common difference is 3. So it's going to be times 3. Okay? So when I do that, that's going to give me A17. So what is, let me do that. What is 16 times 3? That's 48. Plus 22 is 70. Okay? And then I have the first one. So A17 is 76 in that row, the last row. So I'm adding this plus this. So the formula for S, the sum of 17 rows, is going to be 22 plus 70 over 2 times 17. So when I do this math, so 70 plus 22, 92. Then I'm going to divide it by 2. 46 times 17 is 782 seats. Is the total number of seats in that balcony. So everybody see a real world application, right? Okay. Any questions so far? Okay, see guys, you're putting some examples. Okay, yes, that's good. Yes, yes, good job. Okay, so that's what you have. And then the next slide actually is they solve it 782. That's exactly what I got, right? So you have the solution here. Okay, I didn't know. Okay, the next one is geometric sequence. The next type of sequence is geometric. You're going to do that after the break, okay? So we're going to continue with geometric sequences. And the geometric sequence are another type of sequence, another list of numbers, where we have common ratio. That's what you have, common ratio. So the pattern here, the rule is you're multiplying by the same number, or you're dividing by the same number, which is technically multiplying by fraction means dividing by number, and multiplying by number. So multiply or divide by the same number, okay? And again, you have the first term is A1, and the common ratio, it's named R, which is in the formula. So this is your general term. This is your formula for general term if you have geometric sequence. So this is the formula, and this formula is included in the formula sheet. I show you in the beginning. The formula sheet includes the general term for geometric sequence. Okay, let's do example now. So we have geometric sequence. They give me A1 is 1/2, and the common ratio is 3. So that means you're multiplying by 3, by 3, by 3, by 3 every term, right? And here you have to find the 10th term in this progression, okay? So I'm gonna just list some numbers here so you can see how the sequence looks like, and then you're gonna use the general term to find A10. So A1 is 1/2, so this is your sequence. You have 1/2, then when I multiply by 3, it's gonna be what? 3/2, right? And then I multiply by 3 again, it's gonna be what? 9/2. And then what is the next one? 3 times 9 is 27/2, right? So you're multiplying by 3 and so on, okay? So this is how the sequence looks like. So they want us to find A10. So I'm using the formula, so A10 is gonna be A1, which is 1/2, times 3 is the common ratio with exponent n minus 1. So n is 10 minus 1. And then when you put this in the calculator, you're gonna get 9,841.5. And this 0.5 is because of the fraction divided by 2. It's gonna give me 0.5, okay? Everybody understand how I get that? Okay. Then you're gonna go to the next slide, which is finding the sum of the first k terms. And here is the formula. So if I want to find the sum of the first k from term 1 to term k, this is your formula. You're going to multiply a1 times 1 minus r with exponent k over 1 minus r. So that's the formula. You're going to plug all the numbers in that formula, and then calculator is going to simplify it for us, and you're going to have the sum. And let's start with the example. So we have Felipe has been paying into annuity over a period of 10 years. So this is important information, right? 10 years. Increasing his payment by 13% per year. At the end of this time, he had paid a total of, so this is the amount he's paying into the annuity, right? Calculate the amount of his initial payment level. So they're asking, what is A1? Initial payment is A1. So you need to find A1. Okay? So how are we going to do that? The rate is 13%, so it's going to be 0.13 is the rate. But because it's increasing, so the R is going to be 1.13. Why is 1.13? Because it's not just 13%, it's adding 13, right? So if you have 100% now, when you add 13, it's going to be 113%, which is 1.13 in decimal form. So R is in decimal form of the percent, okay? So here, this is the sum Felipe accumulates, so S of over the, how many years? The 10, so this is S10, right? Okay, so this is S10 is given, and we're using the same formula for SK. But in this formula, if you want to find what is A1, I'm going to write the formula for A1 also. So you can solve for A1. So we have A1 equals SK times 1 minus R over 1 minus R with exponent K. So when you solve it, this is what you're going to get. Okay? I mean, how you do that? You multiply both sides by 1 minus r, and then divide by 1 minus r to the k. And that's what you're going to get. So we have, let me write it here, r is 1.13. A1 is the one we need to find, right? We have r, we have k is 10 because it's 10 years, right? And just plug it in into this formula. So you have A1 is, there is the formula actually, they have it here. I didn't see that. So I'm going to plug it in. The SK is the 138,148.12 cents. And then 1 minus 1.13 is going to be negative 0.13 over 1 minus 1.13 with exponent 10. And the calculator is going to give you this number. Okay? Everybody understand that? So the initial payment should be 750. And then if Felipe increase the payment with 13% every year, the annuity is going to grow all the way to after 10 years, 138,148.12 cents. Okay? Everybody understanding this? Any questions? Very good. Okay. So going to the next one is, so the next thing we're going to talk about is the principle of mathematical induction. What is that? The mathematical induction, it's a method to prove a formula. Okay. So this principle proves the formula. And why are you doing that? Because remember, when I give you a sequence and you need to find the formula, you need to find the general term for that formula, you have to prove it that that's the formula you got is correct. Because sometimes the formula you get is it's not going to work for any n. Okay? So that's why you have to use the principle of mathematical induction to prove it. And this is the method. This is how you do the method to prove it. So you have like 3 steps here. So the first step is you check it for n equals 1. Okay? So we are proving formulas with this method. So let's say you set up a formula which is an, your general term is n plus 3, for example. This is your formula you generate from the given sequence. And you want to prove, is that correct? So how are you going to prove that? You're going to check for n equals 1, is it correct? Okay? So in this case, I'm going to make up a little, we have example to prove here. Yeah, we have this example to prove. So I'm going to just talk about the in general. So you're going to prove for n equals 1, is it true? Then after that, you're going to assume that for n is true, and then you're going to prove for the next one. For, I mean, here, k, they're using k. You assume it's true if the fact holds for a particular unspecified value of k. So you assume for k is true. And then you're going to prove the next one. So this for k you assume is true. You're going to assume. And you're going to prove this one. Okay? Everybody understanding that? So that's how you do it. So let's do example. So here you have to prove. We have, this is formula. They give me this formula. Let's say we found this formula and you have to prove it. So this is the first step. We're going to assume, we're going to check for n plus 1, right? So we're going to have, when we have the first term, right? A2, A3, AN, right? These are the n terms. And this is the formula you got. So you're going to check for n equals 1. So n equals 1 is 1 equals, and then you're going to replace 1 in this formula. 1, 1 plus 1, 2 plus 1 over 6. Is that true? So let's check it out. So we have 1 plus 1 is 2. And this is 3 over 6. Is that true? In the top, you get 6 over 6. Is also 1, right? So you get 1 equals 1 is true. So when n is 1, everything works out. The formula is good. Yes? Then the next step, we're going to assume that the formula for n equals k is true. So we're assuming that this equals this. It's true. We assume it's right. Okay? And then the third step is we're going to confirm, we're going to check for k plus 1. Okay? So we have 1 plus 4 plus 9 plus k squared plus k plus 1 squared equals, let's see what is equal. Now, I know this part here is the one from previous step. So this, all this here, when I add it from 1 all the way to k squared, it's k plus 1 to k plus 1, right? Over 6. And I have to add k plus 1 squared. And let's see what I'm going to get. How you do that? You're going to find common denominator. We're going to add it. And you should get it right. I mean, that's how you prove it. Okay? You want to finish this? You want to prove that? Yes?
Yes.
So we're going to add those two. We're going to combine like terms and do the math. It's like algebra, combining it. So let's go ahead and do that. Now, what I need to do, I'm just going to write here how the formula is going to look for k plus 1. So it's going to be, when I use this formula, the one here, I should get k plus 1. And then k plus 1 is going to be k plus 2. And the last here is going to be 2 times k plus 3. So this is what I should get, right? So let's see. I'm going to insert another slide. So I'm going to just do that here. Let me write it here, what I need to do. So I'm checking for n equals k plus 1. I'm going to just write it in this slide so I can have enough room to do it, okay? So I have n. So this is what I'm checking, the last step. Okay, and I'm going to write it here. I have, from the previous slides here, I have k plus 1 to k plus 1. Over 6 plus k plus 1 squared. And this is over 1. So I'm going to add those, and I'm going to combine like terms and simplify. And let's see if I'm going to get this. Now, when I replace n in this formula with k plus 1, I get k plus 1. Then k plus 1 is going to give me k plus 2. And then I have 2 k plus 1 plus 1. This is the last term here. It's going to be 2k plus 2 plus 1 is 2k plus 3. Everybody understand that? So this is what I need to prove. This is what I need to get. So let's simplify and see what we're going to get. Okay, so we have, I'm going to multiply this fraction by 6 up and down to make it over 6, and I'm going to add those, right? So it's going to be k, and then k plus 1 to k plus 1 plus 6 k plus 1 squared, everything over 6 now, okay? Now what I'm doing, I'm going to factor out k plus 1, k plus 1. So that will give me k plus 1 in front. And then I have k, and have this times this left. And I'm going to multiply it. So it's going to be 2k squared plus k plus 6k plus 6. This is what I have, averaging over 6. And then here, let me write this better. I'm going to combine these like terms. And I need to factor this inside to see what I'm going to get, right? So I'm going to have k plus 1. And when I combine this, it's going to be 2k squared plus 7k plus 6 over 6. So now here I can factor it. So I need to see 2k plus what, and k plus what is going to be this. It's going to be k plus 2, and this is going to be 3. Because when I multiply 2k times k is 2k squared, right? Let me write it up here. So 2k squared plus 7k plus 6 is actually 2k plus 3 multiplying by k plus 2. Because this is what happened if I multiply 2k times k, 2k squared, right? When I multiply 2 times 3, I'm going to get 6, right? And then when I multiply those two, let's use different color. So when I multiply 2k times 2, it's 4k, right? And also when I multiply 3 times k is 3k. And when I add those two, it's going to be 7k. That's exactly what you get here, 7k, right? Everybody see that? So 2k squared plus 7k plus 6 is the same like 2k plus 3, k plus 2. So that tells me that this expression becomes k plus 1. I'm going to do k plus 2 first. And then 2k plus 3. Averaging over 6. So let's see if that's the one we have in the previous slides. K plus 1, k plus 2, 2k plus 3 plus over 6. Everybody see that? It's the same. Okay? So when you add them, you're going to get the same. So that, check it out. That means the formula we have there, and the formula is the sum for 1 plus 4 plus 9 plus so on n squared. So this formula works always because you're using the method of mathematical induction, which says the first step is you're checking when n is 1. Then you assume that this is true. So you assume the second step. And then you have to confirm. The next one is you must confirm. Okay? So assume for k, and then you're confirming for k plus 1. And you're confirming when you just write this first sequence, like adding them, plus k squared, k plus 1 squared, and then using what is given from the previous step, and you're adding the last term, and then you're using some algebraic tricks here, adding fractions, factoring, and you're going to get absolutely the same. Make sense? Any questions? You guys understand this? Any questions? Okay, going to the next one then. The next one is binomial theorem. And binomial theorem is, we did this in algebra when you expand binomial. Binomial means you have two terms, a plus b x plus y, doesn't matter, 2 terms, and you erase it to power. In this case, it's power 3 cube. So in order to do that, one way is if you just multiply a plus b, a plus b, a plus b. So this is the way they show it here. And you have to distribute, combine like terms, and this is what you're going to get, right? So that's one way. Another way is using the binomial expansion using a formula. And the formula is given here somewhere, this one. This is the formula using the factorials. And these are the coefficients for the factorials for the binomial. And the way I prefer it's easier is with Pascal Triangle. And Pascal Triangle, I'm going to show you that. I'm going to do example of Pascal Triangle one more time from, it's in algebra, we did that. But I'm going to do one example of Pascal Triangle, and I'm going to explain that one more time. So this is how the Pascal Triangle looks like. So I'm going to start with, delete this, I'm going to insert a better slide. Okay, so I'm going to give you an example of Pascal Triangle. So this is how the Pascal Triangle looks like. So the Pascal Triangle starts with 1, and then you have 1 and 1, and then the next row starts with 1, and then you add in the previous two numbers, 1 plus 1 is 2, and you finish with 1. Remember those triangles? Then you start with 1, sorry, you start with 1, you add in the previous, and that's how you're going to get the next row. So you have 1, 3, 3, 1. And then if you want, you can continue out those two, the previous two. So 1, then 4, and 6, and 4, and 1, and so on. So this triangle can continue, depends, yes, you remember that, yes. So what that means, if I have to do exponent 0, if I have, let's say, a plus b to the 0, the answer is 1, because anything with power 0 is 1. If you want to do a plus b to the first power, the coefficients are going to be 1a and 1b. That's why the Pascal Triangle gives you the coefficients for your answer. If you want to do a plus b squared, okay, because a plus b squared is technically, I'm going to give you a formula, or you can FOIL and you're going to get this. And these are the coefficients. 1a squared, 2ab, and 1b squared. So these are exactly the numbers, 1, 2, and 1. If you expand cube, if you have a plus b cube, these are going to be the numbers for your answer. And here we have actually expanded a plus b cube. So let me show you. The numbers you should get is 1, 3, 3, 1, right? So going back here, what is the answer? So look at this. 1, 3, 3, 1. It's exactly what is here. Okay? So the Pascal Triangle is going to give me the answer. If I want to do a power 4, I'm going to use these numbers, a plus b to the 4. I'm going to use these last numbers, okay? So let's do one example where I can show you how to use that. So let's say I want to do a plus b. What exponent you want to do? Or you can do 2a plus b with exponent 3. Let's do that. So if I want to do that, I'm going to go to power 3. So these are my numbers, 1, 3, 3, 1. I'm going to start with that. I'm going to write 1, 3, 3, and 1. Then next to each number, I'm going to put 2a and b. Because those are my two terms. It's a binomial. I have two terms. I'm going to put 2a, b. The next one is going to be 2a and b again. So I'm going to copy that next to each number. Okay? Then because here we have plus, you're going to connect those with pluses. It's a positive everywhere. If this sign between them was negative, so let's assume this is minus 2a minus b, then it's going to be positive 1, negative 3, positive 3, negative 1. That's how the sign are going to go if the sign between the two terms is negative. Okay, but here we have positive. And then after that, we're going to do exponents. So we're going to start with first term, which is 2a, with the highest exponent is 3. So we're going to start 2a with exponent 3, then 2a with exponent 2, 2a with exponent 1, 2a with exponent 0. So you do the exponent for the first decreasing, starting from the highest all the way to 0. And then you know exponent 0 is 1, so I'm going to cross this out because it's 1. And then you're going to do the b, the second letter. We're going to do it backwards. So we're going to start from the back. b3, b2, b1, b0. And 0, you're going to cross it out because it disappeared. And then that's my answer. I just need to rewrite this, and it's going to be my answer. So how you rewrite it? You're going to do 2 with exponent 3, 8 to exponent 3. 2 cubed is 8, a3. That's the first term. Plus, the same way I'm going to do 2 squared first is 4, times 3 is 12. And then you do a squared, b to the first is just b. Then you do in the next term, we have 2a to the first. Okay? So it's going to be 2 to the first is 2. 2 times 3 is 6. A to the first is just a, and b squared. And then plus, this cross out, so it's 1b cubed. You don't need to put 1 in front. So that's my final answer if I want to expand 2a plus b. Okay? Everybody understanding that? Any questions? Okay? So that concludes pretty much everything we have for today. We'll learn about definition and concepts of sequences, series. Sequence means the list of number. This is the difference. Sequence means you have a list of number like 1 and 3 and whatever, 5 and so on. That sequence. Series means find the sum of, let's say, k is from 1 to 5. And let's say k plus 3. So this is the formula. So series means find the sum. Sequence means you have sequence given. Okay? We talk about a general term. It's a formula which has an equals, and then you have formula in terms of n. Let's say n squared plus 1, for example. And recursive definition is when you have an, and let's say it's an minus 1 plus 3, something like that. Formula which have an minus 1. Summation notation is that sigma symbol. We also talk about arithmetic and geometric sequence. So these are the one with the big formulas. Finding the general term, you have formula for that. Calculating the first k term, you got, if you have the formula, it's easy to calculate the terms. Arithmetic sequence is sequence when you add or subtract the same number. Geometric is when you multiply or divide by the same number. The mathematical induction, that principle helps you to prove a formula, and you have 3 steps. The first step is n equals 1, you check it. The second one, you assume for n equals k is true. And the third one, you prove for k plus 1 for the next one. Okay? And here, binomial expansion using Pascal Triangle. That's the easiest way. When you have 2 terms, like a plus b with exponent, whatever, 5, 10, whatever the exponent. Okay? So this is what we have for this week. Let me know if you guys have any questions. We're going to do more. We're going to talk about this more, but let's see if you have any questions right now. Any questions? Okay, I'm going to stop this. Have a good day for now.